Start with the basics. RINEX, or Receiver Independent Exchange Format, is a universal text-based format designed for GPS data. Imagine you have GPS receivers from different brands, each saving data in its own unique way. RINEX solves this by providing a common language, making it easy to share and process GPS data regardless of the manufacturer. GPS applications. Two main RINEX files are crucial: the observation file, which records what the receiver measures from satellites, and the navigation file, which contains the broadcast data sent by the satellites themselves. This standardization is essential for accurate GPS data processing and post-processing, especially when combining data from multiple sources. Now let's dive into the RINEX observation file. This file captures the actual measurements made by the GPS receiver from all visible satellites at different times, known as epochs. The main types of data recorded include pseudorange, carrier phase, Doppler, and signal strength. For example, pseudorange measures the distance from the satellite to the receiver, while carrier phase is used for high-precision positioning. Observation file starts with a header, which details the RINEX version, receiver and antenna information, and observation types. After the header, you'll find observation records for each epoch, listing the satellites observed and their corresponding measurements. These files are the foundation for calculating receiver position, velocity, and time. Next, let's look at the RINEX navigation file. This file contains the broadcast navigation message parameters sent by GPS satellites. These parameters are essential for determining the satellite's position and clock corrections at any given time. The navigation file includes the satellite's PRN number, clock coefficients, orbital parameters, and satellite health status. For instance, the satellite clock correction is calculated using coefficients AF0, AF1, and AF2, which account for clock bias and drift. The file also provides broadcast ephemeris data such as orbital shape and orientation, which are used to compute the satellite's exact position in space. Together, these details allow GPS receivers to accurately model satellite positions and timing. Wrap up, let's clarify the difference between GPS observation data and navigation data. Observation data are the actual measurements made by the receiver, like pseudorange and carrier phase, recorded for each visible satellite at every observation epoch. Navigation data, on the other hand, are broadcast by the satellites and provide the necessary parameters to determine satellite positions and correct their clocks. In GPS positioning, both types of data are essential. Observation data tells us what the receiver measured, while navigation data tells us where the satellites were and how their clocks behaved. By combining these two, we can accurately determine the receiver's position anywhere on Earth.